Right. So next one, the last question. After that, we'll see that. So you know about the torque, right? What is the torque equation? Tau is equal to with respect to dipole moment. What's the relation? Tau is equal to what happened? Okay, tau is equal to P sine theta. Tau is equal to P sine theta. So this is your relation. Okay, and okay. So what I'll do next week, Monday class, I'll ask questions from your first chapter, electrostatic first chapter, and what are the topics we are completing today. Okay, I'll ask the formulas, only formulas and the units. Okay, clear? I'll ask the questions. So formulas from your first chapter and what are the topics we are completing today. So next Monday I'll ask you that. Okay, right now. So we'll start it. So this is your chapter 2 as per your NCRT. Chapter 2 and as per your NCRT. And remember one more thing, உங்களுக்கு வந்து syllabus reduction இருக்கு NCRT. யாரு CBSE students இருக்காங்களோ, so syllabus reduction it's not applicable for your NEET. So for that I'm covering almost all the topics. So நீங்க வந்து if you are preparing for a NEET and you have to study everything. If you are preparing for your entrance exam, IT also engineering entrance also, you have to study everything. And உங்களுக்கு வந்து the topic is little bit different. So pattern is different, concept is same, pattern is different. We'll discuss it. Okay. So after this class, we'll discuss those seats. நீங்க 3 to 4 members இருக்கீங்கன்னு நினைக்கிறேன். I want to talk with you people. Okay. After the class, just call me. Okay. We'll talk about that. So chapter 2, make a heading. It is your electrostatic potential and your capacitance. Electrostatic potential and your capacitance. And remember one more thing, whatever the topics we have discussed earlier, the similar topics will be there here also. So you have to be thorough with the earlier topics. Then only you can able to understand this one. Okay. Now let's see that. So in these cases, in these things, electrostatic potential, first of all, we'll try to understand what are the things are there. In this electric potential, so we are going to study about the electric potential difference. We are going to study about the potential difference. And after that, we are going to study about the electric potential difference, electric potential, and after that we are going to study about the potential energy. In between, you are going to see your potential difference and as well as the electric field or a small relation irukku, and you are going to see a graph on it. So potential energy and potential energy related, there are two things are there. So one is 2-point charge. 2-point charge and sort of concept irukku. After that, 3-point charge. 2-point charge and after the 3-point charge. And parallelly, you are going to study about your equipotential surfaces. Equipotential surfaces. After these equipotential surfaces, we are going to study about your work function. Small concept work function and so. So these are the cases. And in between, potentially, we are going to discuss about your dipole. Again, dipole is there. Again, there are two applications are there. One is axial point and one is your equatorial point. One is axial point and one is equatorial point. So this is your first set. So electric potential, these are the content we are going to discuss. In your capacitance, first of all, we'll try to understand your capacitance. So capacitor na capacitance na other relations na those concepts we'll discuss. Other unit, everything we'll discuss. And after that, we'll see your relation with respect to your types of capacitors. Types of capacitors. Types of capacitors, so the 3 types irukku. So those 3 types are nothing but first one, isolated spherical capacitor. Second one, your spherical capacitor. Third one, we have your parallel plate capacitor. Fourth one, cylindrical capacitor. So these are the 4 types of capacitor which we are going to study in our books. Okay, and after that we are going to discuss about the energy stored in capacitor. Energy stored in capacitor. This relation is important. After this energy stored in capacitor, how the charges are transferring from one point to other point. So we call it as redistribution of charges in a capacitor. Redistribution of charges in a capacitor. And after that, you are going to study about your capacitance and as well as your dielectric. So with respect to capacitance, with respect to your dielectric, there are 2 things are there in that. So this relation is important for your board exams. So it is your 5 marks question along with a problem. So the concept is dielectric slab. Okay, so I'll write here itself. Okay, so there are two relations are there. One is your capacitor with a dielectric slab. Capacitor with dielectric slab. Capacitor with dielectric slab. This relation is important. So it was your 5 marks question along with the problem. Easy only and important. And next one is your capacitance with the conducting slab. With conducting slab. So these are your contents in your electrostatic potential and as well as your capacitance. In this, the most important content is nothing but your equipotential surfaces. We may get theory questions on it. Potential energy, we may get problems on these cases. And you have to understand your potential energy relations, electric potential, potential difference. And after that, the types is important. And after that, the capacitor with the dielectric slab. In between, you will study about the series and parallel connections. Series and parallel connection of capacitors. Okay, so these are your contents in your chapter 2. Okay, just remember these cases. So either on the just for your understanding only I have given you. So we are splitting into two parts. We'll try to understand today itself this one, and in next class we'll try to understand your capacitance. Okay, so I'll go slowly. First of all, let me complete the concepts, then we'll do the problems. Okay, if you have any doubt, you can stop me there. You can chat there itself. Okay, I'll save it and I'll delete it. Let's see. One by one we'll see. So make a heading. Make a heading. First one, potential difference. Potential difference. Potential difference. So I'm not going to give you a definitions and all. So the relation is same. So potential is difference is nothing but I'll give the formula itself. I'll explain that how the formula will be there. So it is VAB is equal to VB minus VA is equal to work done by charge. Okay, this is your relation. Let's see that. So with the help of some examples, I'll try to teach you. And in an easy way, you can remember it. Now, so assume that, and before that, so the potential difference, those who don't know about the voltage, just remember potential difference is nothing but your voltage. Potential difference is nothing but your voltage, and the unit for voltage is nothing but your volt, and the symbol is V. This is nothing but your voltage, V. Okay, it is nothing but the difference between the higher potential to the lower potential. Difference between the higher potential to the lower potential. This is nothing but your potential difference. Okay, let's see that. So, koncham understand panikla. So what I'll do, I'll take a charge. I'll take a positive charge. I'll take this positive charge as a source. I'll take this positive charge as source. So for this positive charge, I'll take it as capital Q. So for this positive charge, they'll be having some field around it. For this positive charge, they'll be having some field around it. This field, we call it as your electric field. What are the field I'm drawing here? This is nothing but electric field for this charge. Now what I'll do at the infinity location, the far away infinity location, I'm placing a positive, unit positive charge. A small unit positive charge. Unit positive charge. This positive charge, I'll take it as small q, and I'll take it this one as test charge. I'll take this one as test charge. So if I end up on now, what I have to do, I have to bring this positive charge, okay, from infinity location to the point B on your surface. Okay, so the electric field on a surface B work, I have to bring it. Assume without a distance on that, I'll take it as R. Okay, now, so I have to do some work, then only I can able to shift this positive charge from the infinity location to the point B. So I'll take this point as A point. Okay, I'll take this point as A point. Now, if you see that when I'm bringing this positive charge, that means I have to do some work. I have to do some work. Acting this object force, that means if you remember that, so class 11th law, there is a force, there is a relation, work done is equal to force into displacement and solid. There's a small equation. Work done equal to force into displacement. So this is your fixed force. Remember, this relation is your fixed force. And when we are discussing about the variable force, on the infinity location, the displacement may can change step by step. That moment, there will be a small segments of work function will be there. dW is equal to F into ds. Okay, and when you're taking the integration, integral dw is equal to integral f into ds. So w is equal to integral f into ds. It is initial point to the final point. Remember this relation, we call it as a variable force. So it is with respect to your variable force. Again, work function. This is class 11 topics further. When you're discussing this one, you can remember it. Okay, now next one. So when you're doing some work, so shifting this object from infinity location to the point B, it was varying from A point to B point. That means I'm applying some force here. When we are applying some force, then only the test charge is moving from infinity location to the point B. So when it is moving, that means there is a difference between the two potentials. There is a difference between these two potential. The difference at the potential, it is VA. I'll take this as VA, the potential difference, and I'll take it as a VB. I'll take it as VA and I'll take it as VB. Now, when I'm bringing this infinite location charge to the point B, after reaching the point B, because of the source, either positive, when you're placing the positive charge here, what will happen? It will try to ripple. It will try to ripple. Okay, remember it. So it will try to ripple and it was moving in opposite direction to the work function. Work function in the direction. So the ripple and a force in the opposite direction. So remember that cases. So one by one we'll discuss. First of all, we'll try to understand your potential difference between the points A and B. The potential difference between the points A and B is equal to, always remember, we have to take the difference from final to the initial point. So it is the difference between VB minus VA. So is equal to, that means, and the difference were the reason because of the work function. The work will be there from the positive terminal or infinite location to the positive terminal at the B point, which is the radius of R. So that means it was varying from B point towards, that is your A point towards the B point. So A point is your initial point, B point is nothing but your final point, which is equal to work done, which is between A to B divided by the test charge. Remember, this is your potential difference. VAB is equal to VB minus VA is equal to work done by charge. Now, so this is your potential difference. Now we'll see the unit for this potential. Unit answer number, the work done is nothing but joule. Work done is nothing but joule and charge is nothing but coulomb. So we can say joule per coulomb or volt. Joule per coulomb or volt. If you forget the units, okay, just remember the relation. With the help of your relations, you can able to find the units. Okay. Now, so let's see one more thing. So whatever the relation we have seen here, this is nothing but your potential difference. In the potential difference, let's see your potential, electric potential. Electric potential. So for this electric potential, we are taking the potential at a point location, at one particular point location, one point located. It is related to one point locations. One point location. Okay. Now, so to find the electric potential at one point, okay, what I'll do at the infinity location charge on the 0 பண்ணிடுறேன். Infinity location charge on the it is VA. So VA is equal to 0. When VA is equal to 0, on the infinity location I don't know what is the charge. So I'll take the potential VA is equal to 0. And I know the charge, I know the potential at B point itself. So when you're taking potential at one particular point, that is at the B point, so VAB is equal to, it is a VB minus VA is equal to, இங்க வந்து VA நான் வந்து 0 பண்றேன். I'm making VA is equal to 0. When VA is equal to 0, it is nothing but your VB is equal to work by charge. Remember, it is your electric potential. Last same units are, which is nothing but your volt. Okay. Potential difference and two different points. Remember it. Potential on one single point. Okay. So this is your relations. Potential difference and potential. Please take it. Units is same. Volt joule per second. Noted? Just take this one now. Then we'll see next one. Orma. Others, is it over? Okay, let's see that. So I'll delete it. Okay, ma. So next one, make a heading. Next one, make a heading. Electric potential due to a point charge. Electric potential due to a point charge. Electric potential due to a point charge. Okay, so everything is same. Only we are going to see the relation with respect to your potential. So make a heading. Electric potential due to a point charge. Okay, right. So same example, same thing, everything is same, but we are going to see the potential with respect to your force and as well as your work function. நம்ம ஜஸ்ட் வந்து ஒர்க்குக்கு அண்ட் சார்ஜுக்கு பொட்டன்ஷியலுக்கு ரிலேஷன் மட்டும் தான் பார்த்துப்போம். ஒரு ஃபார்முலா எப்படி இருக்கு, ஈக்குவேஷன் எப்படி இருக்குன்னு பார்ப்போம். Now if you see that same thing, everything is same. Now we have seen the work function will be there between the A and B points and the charge மேல தான் work function act ஆயிட்டு இருக்கு மட்டும் தான் நம்ம பார்த்துருக்கோம். Now so if you see that, so what I'll do, so in the center point, in the charge at a center point nandu, I'll take the distance from the infinite location, I'll take the distance as x. Remember that. So the total distance from the center to the infinite location, I'll take the distance as x. And what I have to do, so charge வந்து நான் A point வந்து B point shift பண்ணணும். அந்த B point ஓட radius தான் r from the charge. So இது வந்து அதோட border for this field. Now, when you are doing it, so when you are shifting from infinite location to the point B, that means I'm doing some work and சொல்லிருக்கேன். Work பண்ணும்போது, when we are keeping this on the B point, what will happen? It will try to ripple. நல்லா பார்த்துக்கோங்க, there'll be having some repulsive forces acting on this unit positive charge. Acting on this unit positive charge. நான் unit positive charge மட்டும் தான் discuss பண்றேன். Then only they can feel the, we can see the potential difference here. Okay, so they'll be having some repulsive forces acting on it. Now we'll see the equations. So if you remember that W is equal to Fs cos theta. இது நம்ம வந்து as usual நம்ம வந்து class 11ல படிச்சிருந்தோம். If you see that work வந்து உங்களுக்கு towards work வந்து left side இருக்கு. And force acting வந்து it was towards your right side. So both are in opposite direction. When both are in opposite direction, cos that is theta is equal to 180 degrees. So because of the cos, it was within its own axis, x-axis and சொல்லும்போது cos theta. So the relation will be Fs cos 180 degrees. So cos 180 degrees is nothing but your -1. So the W is nothing but your negative force acting on it. Remember this case. Work on the negative force actor, negative work done. Now, we'll see the relations. இது வந்து ஜெனரல் ஈக்குவேஷன் நம்ம வந்து கிளாஸ் 11 டாபிக்ஸ் பேஸ் பண்ணி டிஸ்கஸ் பண்றோம். நான் இப்போ இந்த ரிலேஷன் பேஸ் பண்ணி பார்க்கும்போது, so when you are bringing this charge from infinite location to the point B, that means there is a force acting between these two. So there is a Coulomb's law. So F is equal to K capital Q small q by the distance between the two charges is nothing but your x square. I'll take this one as first equation from the Coulomb's law. Okay. Now next one, the work function. So we know that it was variable. So continuously change the displacement. Step by step. There is a work function here. The displacement will changes. Displacement is nothing but dw, and the work function is nothing but your dw and dx. Okay. So the relation will be dw is equal to your f into dx. F into dx, and vector is the work is a scalar quantity. Remember it. Work is a scalar quantity. Scalar irukadanaala we are seeing the dot product, and force and displacement both are having directions. Okay, now and inge vandu cos 180 degrees, cos 180 vandu -1 and சொன்னதுனால, so it is cos 180 degrees, and I'll take the relation as minus f vector into dx. Now we are going to find the work function here. So w is equal to integral dw, which is equal to integral f into dx, f into dx, and it is minus. And இதோட லிமிட்ஸ் பார்க்கும்போது நான் ஆல்ரெடி சொல்லிட்டேன், இனிஷியல் பாயிண்ட் டு த ஃபைனல் பாயிண்ட். இனிஷியல் பாயிண்ட் வந்து இட் வாஸ் ஃப்ரம் த சென்டர் பாயிண்ட் வந்து இது இன்ஃபினிட் லொகேஷன் இருக்கு, அண்ட் நான் வந்து என்ன பண்றேன், பி பாயிண்ட்க்கு ஹேவ் டு ஷிஃப்ட். So when you are shifting it, the initial point is infinite location, the final point is nothing but your radius r. I'll take the Kepler. This is your Kepler. Now remember it. So this is your second equation. Now what we are going to do, so we are going to substitute this first equation in the second. When you're doing it, so minus is always constant, minus, okay, so when you're substituting it, k is constant, capital Q is constant, small q is constant, and which is integral infinity to r, so it is 1 by x square into dx. This is your relation, 1 by x square into dx. Now in this case, so integration, there is a small relation, there is a small formula. So I'll give the relation also. So the relation is nothing but your integral x power n into dx. Remember this, when you're integrating the power terms, integral x power n into dx, the same terms irkumbodhu, the relation is x power n plus 1 by n plus 1. Remember this relation, x power n plus 1 by n plus 1. Okay, now, so let's see one more. So we got the work function, we are going to integrate it. So when you are doing the integration, the final relation will be like this. So integrate பண்ணும்போது, so the relation will be W is equal to minus K capital Q small q integral. So integral here infinity to R, it is x power minus 2 into dx. X power minus 2 into dx. So instead of n, நீங்க வந்து minus 2 substitute பண்ணுங்க. So it is x power minus 2 plus 1 by minus 2 plus 1. So can I say that x power minus 1 by minus 1, or I can write as minus 1 by x. So this is minus k capital Q small q, it is minus 1 by x, limits are infinity to r. So if you see that xx will get cancelled here, xx will get cancelled. So now instead of x, what I'll do, I have to substitute the limits here, upper limit and the lower limit. When you're substituting the upper limit and the lower limit, the relation will be like this. So W is equal to, it is K capital Q small q 1 by R minus 1 by infinity. 1 by infinity is always 0. So the work function is equal to, it is K capital Q small q by R. This is your work. Now we are going to find the potential, electric potential due to that particular point charge. About this point charge, we know that potential B is equal to W by Q. And the Q on the source charge and the Q on the test charge. Remember it. So work is acting on the your test charge. So when you are remembering the formula, just remember it. So work function, it was acting on the test charge. So we'll see the relation. So I can write this relation, W by small q is equal to your K capital Q by R, where W by small q is nothing but your potential B. So this is your equation. Remember it. Okay. So this relation is important, and K is nothing but your, and always remember that whatever the terms we are discussing here, we are discussing in your vacuum. Okay, that is your epsilon naught. Epsilon naught is equal to 8.854 into 10 power minus 12, and the K value is nothing but your 9 into 10 power 9, which is equal to 1 by 4 pi epsilon naught. So just take these relations now. If you have any doubt, please ask me later. Is it over now? What about others? Yes, sir. Okay, fine. So I'll delete it. We'll see small graph here. So relation between potential and your electric field. So I'll delete it. So let's see the relation. So we know that LR case V is equal to 1 minute. I'll save it. I'll share it to you. It will be useful for you. So V is equal to. So the relation is. So இப்போ நம்ம பார்த்தது V is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. So the relation is nothing but your Q by R. 1 by 4 by epsilon naught, it is Q by R. So which is nothing but your work by your test charge. Remember, this is your relation. Okay, now, so with respect to this equation, with respect to charge and the distance, and we are going to compare with your electric field. Electric field relation on the, it is a K Q by R square. R is nothing but your radius here. So I can take the capital R itself. So KQ by R square. Okay, now, so V is equal to, it is a K Q by R and VE is equal to KQ by R square. Let's see the relation between these two. What I'll do, I'll take the ratios. So V by E is equal to, it is K Q by R divided by KQ by R square. So R will get cancelled, QQ will get cancelled. Okay, so electric field E is equal to V by R. Remember this case. Okay, so in the relation of the important and similar to that equipotential surface நம்ம பார்க்கிறோம். So E is equal to minus dV by dr. And then அந்த cases நான் சொல்றேன். Remember this equation. So electric field base பண்ணி உங்களுக்கு problems வரும், potential அதோட radius base பண்ணி problems வரும், relations base பண்ணி work base பண்ணி problems வரும். There are so many relations. Okay, let's see a small graph with respect to your distances. With respect to your distances. So we know that electric field E is equal to, it is KQ by R square. And V is equal to your KQ by R. So here if you see that, so charges can be constant, but the distances will be varied. It depends upon the distance, the potential can be varied. So E is proportional to 1 by R square and V is proportional to 1 by R. So almost both are inversely proportional to each other. So what I'll do, I'll take a small graph here, okay, between these two. So when you see the graph, so the x-axis I'll take it as R, the distance. X-axis I'll take it as R, and y-axis I'll take it as, first of all, we'll see your electric field. I'll see the graph for your electric field. So electric field will be graph is like this. It is like a parabola. It's like a parabola. Completely it will be like this. And this is your electric field. And always remember when you are writing in your board exams also, in a school test, graph note just mention the formula or the relation there itself. You have to write it. Okay, and after that, when you are taking the graph for your potential y-axis, again I am taking the potential. So potential and your distance now the vary பண்ணும்போது it will be crossing with each other, and this is your graph. So almost similar to each other. So it is K Q by R. So this is your graph between your electric field and electric potential. Okay, so remember this one and the formula note பண்ணிக்கோங்க. Then we'll see the next one. Is it over? Right now. So let's see. Super. Okay. So I'll delete it. Let's see. Make a heading. Electric potential due to a dipole. Make a heading. Electric potential due to a dipole. So நான் already சொல்லிட்டேன், கான்செப்ட்ஸ் எல்லாம் ரொம்ப சிம்பிளா தான் இருக்கும். So if you are thorough with your electrostatic first chapter, first relations அந்த காஸ்ட்ல அதோட ரிலேஷன்ஸ், எலக்ட்ரிக் ஃபீல்ட் அதோட கான்செப்ட்ஸ் எல்லாம் நீங்க தரவா இருந்தா இந்த டாபிக் எல்லாம் ரொம்ப ஈஸி. It won't take much time. Okay, the sequence of flow ஆயிட்டே இருக்கும். Okay, just remember, if you are thorough with your electrostatics completely, magnetism topic is so easy for you. Okay, so remember it. So next one, next heading, make it electric potential due to a dipole. Electric potential due to a dipole. Due to a dipole. So can anyone tell me what is a dipole and what is dipole moment? What is dipole and what is dipole moment, ma? கொஞ்சம் அன்மியூட் பண்ணிட்டு பேசுங்க ப்ளீஸ், சாட் பண்ணாதீங்க. ஓகே, ரொம்ப போரிங்கா இருக்கும்பா பிசிக்ஸ் கிளாஸஸ் பேசாம இருந்தா. உங்களுக்கு எப்படி இருக்குன்னு தெரியல, எனக்கு ரொம்ப போர் அடிக்குது. ஓகே, யா ப்ளீஸ், வாட் இஸ் டைபோல்? எனிவன்?
Two equal and opposite charges separated
Yes.
by small distance.
Yes. What is the unit for dipole moment? What is the unit for the dipole moment? Already நான் கொடுத்துட்டேன்.
Coulometer.
Yes, ma, coulometer. And can you say that dipole moment, is it a vector or scalar quantity? Is it a vector or scalar quantity? Yes, ma. So in which direction it will travel?
Negative to positive.
Good. So dipole moment travels from your negative towards the positive. Now, so we'll see your dipole with respect to your electric potentials and all. Okay, let's see that. So make a subheading. So a subheading, electric potential at an axial point of a dipole. Electric potential of an axial point of a dipole. Electric potential of an axial point of a dipole. Okay, let's see that. So what I'll do on the axial point, நம்ம வந்து electric field வந்து எப்படி டிஸ்கஸ் பண்ணிருக்கோமோ same thing electric potential நம்ம டிஸ்கஸ் பண்றோம். So it doesn't change at all, everything is same on the same axis. So assuming on the same axis I'm taking a point P. On the same axis I'm taking a point P, so which is away from the dipole. So let's see the distances. From the center I'll take the distance to the point P as x. From the center I'll take the distance to the point P as x. Now for the convenience, what I'll do, I'll take the points as A point and I'll take the point as B point. Okay, so from B point to P point, the distance will be, it is x minus L. And from the A point to the P point, the distance will be, it is x plus L. So these are your distances. It won't change on the axial points. Now, let's see that. So we know the distances. We need to find the potential on the axis, which is away from the dipole. So we are going to find the potential here. So remember one thing, electric potential irundhalum, force irundhalum, okay, electric field irundhalum. So only one property, that is your additive property only, that is we call it as superposition. So we'll discuss in later classes about that. Okay, superposition adu நம்ம வந்து later classes la varum. So remember V is equal to, we are going to find the potential from A point to the P point. So finding the potential between A point to the P point, we call it as VA. Same thing from the B point to the P point, we call it as VB. So we are adding both potentials here. So இங்க வந்து directions கிடையாது. Always remember, vectors நான் இது வரைக்கும் நான் வந்து direction கொடுக்கிறேன். So it is nothing but your scalar quantity. இது வந்து difference மட்டும் தான் நம்ம எடுத்துட்டு இருக்கோம். Okay, so it was traveling from one point to the other point. That's it. Okay, now let's see that. What is VA? So VA is equal to, it is K Q by the distance from A point to the P point is nothing but your x plus L. A point to the P point is nothing but your x plus L. And we know that A point is nothing but your negative charge. I'll take it as minus. And let's see for the VB. VB is equal to K Q by the distance is nothing but B point to P point. It is x minus L. And it is positive charge. So at point P, we are going to find the potential V, that is equal to VA plus VB. So we know VA, I'll take this one as V axial. VA is equal to, it is minus KQ by x plus L. Same thing for KQ by x minus L. So what I'll do, KQ, I'll separate it. When I remove KQ, it is nothing but minus x plus L plus 1 by x minus L. So which is equal to, I'll cross multiply it. When you do the cross multiplication, the relation will be minus x plus L plus x plus L divided by, it is x plus L into x minus L. Okay, so you see that minus x plus x will get cancelled. Okay, so 2L, so it is q into 2L into k divided by, it is a plus b into a minus b format. So it is x square minus L square. So q into 2L is nothing but your dipole moment. P into k by x square minus L square is equal to b axial point. Okay, remember these cases, it is on the same axis. Let's see. Okay, take it ma. So in the squares illa, cubes illa, it will be easy for you. Okay, right? This is a small case or special case. In this itself, there is a special case. So so the distance x is much greater than a. So in the squares, what I'll do, I'll take if distance x square is much greater than a square. Distance x square is much greater than a square. So in the x square greater, now we can neglect a or L. So now L L. So L is nothing but your distance. I'll take it as L square. So when you take it, so V axial is equal to, I'll take the relation V axial is equal to, it is Kp by x square. V axial is equal to Kp by x square. Yes, ma'am. Take it. So this is your axial point. Or others? Completed. Yes, sir. Okay. Right. Okay. So next one. Let's see next one. Next is subheading. So either whatever we are discussing here, it is under your dipole only. So next subheading for your dipole case. Second one, electric potential at an equatorial point. Electric potential at an equatorial point. Equatorial point of a dipole. Of a dipole. Electric potential of an equatorial point of a dipole. Okay, right. Let's see that. So same dipole. So it doesn't change at all. So I'm taking a dipole here. So for this dipole, so the perpendicular point, there'll be having some perpendicular point on it. I'll just write here. So for this one, there is a center. So from the center, there is a perpendicular point. So this is your perpendicular point. Okay, now, so in this perpendicular point, again, charges pakumodu, there will be having some negative charges, there will be having some positive charges. Ellame same da. It is center, it is L, and it is L. The total distance is nothing but your 2L. And remember, sometimes on the syllabary on the questions varum. So inge on the 2L da eduthirukanga, textbook la on the 2A irukku. It doesn't matter. So I'm just taking, so it is as L. So நீங்க வந்து இதுதான் எடுக்கணும் அதுதான் எடுக்கணும்னு இல்ல. Okay, when you're discussing about the length, அங்க specific-ஆ ஒரு electric field-னா இதா எடுக்கணும். அந்த cases வேறு. Length and சொல்லும்போது we can take either. So now, so I'll take this negative charge as A point, I'll take this positive charges as B point. So as usual, the distance from center point to the point at the top, I'll take it as P point. I'll take the distance as X. Already electric field and the dipole path, same concepts on it. Now, so what we have to do, we have to find the potential at the P point. So the potential at the P point is nothing but equal to, I'll take it as E, V. V is equal to VA plus VB is equal to VA plus VB. So first of all, we have to try find the distances from A point to the P point. Same thing from P point to the B point. It is like a equilateral triangle. It was making angle theta. Here also it was making angle theta. So we know the adjacent side, we know the opposite side. We need to find the hypotenuse other than distance to the P point to the B point and P point to the A point. So what I'll do, I'll draw a right angle triangle here. So this is your making an angle theta. So this is your P point. This is your center point. I'll take this one as B point. So this is your X and this is your A. So from the Pythagoras theorem, so opposite side square plus your adjacent side square is equal to your hypotenuse square. So our square root of it is opposite side square, it is X square plus your distance is nothing but your L square is equal to hypotenuse. So we know the relation, it is nothing but your square root of X square plus L square. Now we'll take the potential VA first of all. So VA is equal to so it is negative charge, so I'll take it as negative minus KQ, that is your source charge. So I'll take it as KQ. So divided by the distance, it is square root of X square plus L square. And same thing, it is VB. VB is equal to KQ, but B charge is your potential, positive charge, it is nothing but the same distance, X square plus L square. Now we are going to find the potential at the P point. So I'll take it as VE is equal to VA plus VB. Just see that render distance is same, render charges is same, but potential is not the difference. So if you see the relation, when you added these two, it's nothing but your minus or plus, both will be cancelled. So potential at P point where it is perpendicular is equal to 0. Remember this case. So potential on the perpendicular point equal distance when you are taking the addition, it will be 0. So this is your relation. So just take it. This overcome pandradha, there is one more thing is here. So we have to do it. Take it. Varma. Others? Okay. Okay, let's see. I'll save it, I'll delete it. Let's see the third case. Third case on the relation the important. Yes, sir. Okay, fine. So third case, the relation is important. Let's see that. So the heading is at any, we are taking at any general point. Okay, the heading is electric potential at any general point. Electric potential at any general point. At any general point general point, okay, due to a dipole. Due to a dipole. So we are taking electric potential at any general point due to a dipole. So let's see that. So instead of taking axial point, that is your x-axis base பண்ணி எடுக்கலாம். So இல்லைனா வந்து perpendicular point, that is your y-axis base பண்ணி எடுக்கலாம். So ரெண்டும் எடுக்கும்போது we already seen it. Instead of taking that 0 degrees or your 90 degrees cases, so we'll take any one general point. Okay, let's see that. So what I'll do, I'll take a dipole as usual. This is a dipole. So from the center, so distance எல்லாமே சேம் தான், இது மிஸ் பண்ணாதீங்க. இது distance, இது minus q, இது plus q. I'll take this point as a point, I'll take this one as b point, I'll take the distance as l. Please கொஞ்சம் மியூட் பண்ணுங்கம்மா, என்னோட வாய்ஸ் எனக்கே கேக்குது. Thank you. நீங்க எப்படி பேச மாட்டீங்க, என்னோட வாய்ஸ் எனக்கே கேக்குது. தனியா பேச வேண்டியதா இருக்குமா? Okay, so it is a o and this is your l distances. Now so let's see, I'll take a point which is perpendicular, I mean sorry, it is general point, any general point making an angle theta from your dipole. So I'm taking any general point at a faraway distance. So a faraway distance lo or angle theta on the place பண்றேன். This angle theta, it is with respect to a dipole. So this is your angle theta from this center to the point P. Okay, so now அதே மாதிரி I'm going to find the distances. அதே மாதிரி when we are taking the distances from A point to the P point, let's see that A point to the P point, and the same thing B point to the P point. Okay, A point to the P point and B point to the P point. So it is any general point and சொல்லும்போது இதோட distance எப்படி இருக்கும் பார்க்கலாம். So when you're taking the distances, so A to P, I'll take the distance as R1. R1 because they are having some direction, so I'll take R1. So and B point to P point, I'll take it as R2. And origin on the other, there is a position vector, so I'll take this one as R vector. Okay, the R1, the R2, the R vector. Let's see the potential at P. So V is equal to, it is VA plus VB. V is equal to VA plus VB. Let's see that. So first one VA பார்க்கலாம். So VA is equal to your K minus Q by R1. Okay, VA is nothing but minus KQ by R1. Let's see VB. VB is equal to, it is KQ by R2 and it is plus. So now we are going to find the potential V. I'll take it as VB because it is at any general point. So I'll take it as VB. VB is equal to VA plus VB. So VA is nothing but your minus KQ by R1 plus it is KQ by R2. So KQ is common. So here I'll write it as 1 by R2 minus 1 by R1. When I do the cross multiplication, KQ into R1 minus R2 by R1 R2. This is your relation. It is at VP. Okay, let's see that. So here, if you see that the point P is far away from it. The point P is, it was so far. So far which we cannot able to measure it. Okay, for that, to make it comfortable, and it is not at all zero. R1 R2 two different terms. What I'll do, so to make it comfortable, I'll take a perpendicular line from your R1 line. So I'll make a perpendicular line from your R1. So it was meeting at the B point. So if you see that, it is your perpendicular line. It is your perpendicular line, and we know that whatever the angle theta it was making here, because of the parallel, it was also same angle here. Okay, so our perpendicular line theta. So this perpendicular line, it is similar to your R2. When it is similar to R2, I'll take this distance as R1 minus R2. I'll take this distance as R1 minus R2, and the upper part will be R1 R2 rendu same irukkranaala, it is like a potential. It is like a potential. So this positions V is equal to 0 because potential madri irukku, R1 R2 rendu same irukku. Ena vandu R2 portion na remove pandren. When both are same, the potential V is equal to 0. Now what we have to find? We have to find R1 minus R2 find out pannom and R1 R2 find out pannom. Let's see first of all R1 R2. For the first case, if you see that R1 R2 both are same, then only the potential V is equal to 0. I'll take R1 R2 is both are same, so I can write it as R1 into R2 as R square distances. I'll take it as R square distances for the first case. Now let's see for the second case. So I'll redraw this question. I'll redraw this picture. Okay, I'll take this point as X. I'll redraw this picture. Right angle triangle nala. So I'll redraw this one. This is your line X. This is your line X, and this is your point A point. Okay, and the perpendicular. So when you draw the perpendicular, this point is nothing but your B point, and A to B is nothing but your dipole here. A to B is nothing but your dipole. So இதுதான் வந்து நான் கொஞ்சம் redraw பண்ணிருக்கேன். So by changing its position, that's it. So angle theta எங்க பண்ணிட்டு இருக்கு? This is your angle theta. இதுதான் perpendicular. இதுதான் base. So x to A point, we know that is nothing but your R1 minus R2. And AB, we already know that is nothing but your dipole, that length is nothing but your 2A. So what we need to find? We need to find your displacement, that is your adjacent R1 minus R. For that, what I'll do, I'll take cos theta. Because opposite, I don't know. I don't want the opposite. I need the adjacent. So cos theta is equal to R1 minus R2 by 2L. So from this relation, I can write it as R1 minus R2 is equal to, it is a 2L cos theta. R1 minus R2 is equal to 2L cos theta. And we already know R1, R2 is equal to R square. So these are the two relations. What I'll do, I'm going to substitute here. So when you do that, so what will happen? VP is equal to, the potential VP is equal to, so is equal to KQ cos theta. R1 minus R2 is nothing but 2L cos theta divided by, it is R square. And we already know Q into 2L is nothing but the dipole moment. So I'll take this relation as, I'll take the final relation as, it is Kp cos theta by R square. Remember this. Vp is equal to Kp cos theta by R square. Either any general point, just remember it. It is nothing but any general point. So we'll do some special cases. Okay. After that you can take it down. So special cases, so instead of angle theta, so I'll do that theta is equal to 0 and theta is equal to 90 degrees. We'll take the cases. So this is your relation. And remember, V is your scalar quantity. Remember, V is your scalar. So K, Q, that is your P. P is your vector quantity. Okay, P cos theta. Okay, so vectors and சொல்லும்போது உங்களுக்கு வந்து angle theta வராது. Vectors and சொல்லும்போது theta வராது. So I'm just taking the general. So divided by R square. So if I'm taking in vector format, so V is equal to K P vector into the direction. Direction என்ன direction இருக்குன்னா அது position direction தான் இருக்கு from the center. I'll take this R cap divided by R square. This is your vector form. Now, special case. Special case. For the special case, if theta is equal to 0 degrees, if theta is equal to 0 degrees, cos 0 is nothing but your 1. So that is nothing but your axial point. That is nothing but your axial point. So that moment, what will happen? V is equal to Kp by R square. So that means, in the case, when dipole is shorter. When dipole is shorter. When dipole is shorter. Second case, if theta is equal to 90 degrees, if theta is equal to 90 degrees, V and 0 agum. Yena on the equatorial. So these are the two different cases. Okay. So please take it. So step by step note panikonga. Special cases on the last note panikonga. So on the pink color portion, this is your last portion. First draw the picture. Okay, try to understand the picture. If you have any doubts, please ask me. Okay. So special case last note panikonga. So you just start like this sequence. Do it, make it fast. Okay. This. Yes. Okay. What about others? Is it over? Super. Okay. ஒரே நாள்ல complete பண்ணாலும் difficult தான். Okay. So till that we'll stop and we'll do some problems step by step. Okay. So after this, we are going to see your potential energy and the relations எல்லாம் இருக்கு. First of all, we'll be thorough with respect to these problems. Okay. One by one we'll go. So any doubts so far? I'll send you as I'll share these screenshots to you people, as well as I'll share the video also. Okay. So let's see. So I will delete it. So let's see some problems. One minute. I'm just getting the 1 minute. ஸோ உங்களுக்கு வந்து அந்த ப்ராப்ளம்ஸ் எல்லாம் ஞாபகம் இருக்குன்னு நினைக்கிறேன். How we had done the problems and all. Let's see one by one. Okay, so take the second question. I'm just displaying the answer also. So it will be useful for you. Just displaying the answer also. Okay, so this question. So now step by step. First the basics and the bola. So first we'll try to understand how to do the potential. After that we'll do the critical questions and all. Okay. In this question, is it clear? PDF clear இருக்கா? Can I able to see the PDF? மெசேஜ் பண்ணலாமா? PDF clear இருக்கா இல்லையா? Can you able to hear me or not? Yes, thank you. நிவேதா, ஜாய்ஸ் மேரி. ஜாய்ஸ் மேரி அப்பப்போ வந்து ஒரு ஒரு சவுண்ட் கொடுத்துட்டே இருமா. எல்லா பேரும் பேச மாட்டாங்க. நீயாவது பேசு கொஞ்சம். ஓகே. சரி இருக்கீங்களா இல்லைன்னு தெரிய மாட்டேங்கிறது எனக்கு. ஓகே, ரைட்மா. So example 2, just take this question. So determine the electric potential at surface of the gold nucleus. Surface of the gold nucleus, we are going to find the potential. So always remember surface lo potential இருக்கும் and நம்ம கேஸ் step by step தான் நம்ம பார்க்க போறோம். But before that I'll tell you. So ஒரு sphere ன்னு சொல்லும்போது the potential will be constant. Center நந்து surface வரைக்கும் the potential is always constant. Remember it. Potential always constant ஆ இருக்கும். Okay. So here they have given the radius and they have given the atomic number. Atomic number is nothing but your n, number of electrons, which is 79. Okay. And given the charge on the proton, they have given the charge on proton 1.6 into 10 power minus 19 coulomb. So what we need to find? We need to find the potential V. So the formula is KQ by R. Q is nothing but your N times E. Okay. So the relation is KQ by R, which is equal to K into N times E by R. So try to find the relation. Answer வருதான் check பண்ணுங்க. Clear? Is it over? And I forget to tell you that. So இதுல வந்து நம்மளுக்கு integration part இருக்கு, differentiation part இருக்கு. Okay, so for that what I'll do next class, not this class, next class. So we are going to see a shortcuts for your square roots and cube roots. Okay, ரொம்ப ஃபாஸ்டா நம்ம வந்து சால்வ் பண்ற மாதிரி and just I'll teach you that. So let's see என்னென்ன டாபிக் சப்போஸ் நான் வந்து forget even if I forget please remind me. So next class on Monday we are going to see your shortcuts for your square roots. ஸ்கொயர் ரூட்ஸ்க்கு ஒரு ஷார்ட்கட் பார்க்கலாம் பிகாஸ் ஷார்ட்கட்ஸ் நம்மளுக்கு ரொம்ப தேவைப்படுது பிசிக்ஸ்ல ஈவன் ஃபார் நீட் அண்ட் ஐடிஸ் ஆல்சோ. அண்ட் ஃபார் திஸ் ஷார்ட்கட்ஸ் ஸ்கொயர் ரூட்ஸ் நான் சொல்றேன், கியூப் ரூட் ஐல் டெல் யூ தட். ஓகே, ஸோ பர்ஃபெக்ட் நான் பர்ஃபெக்ட் ஸ்கொயர் ரூட்ஸ் கியூப் ரூட்ஸ் இருக்கு, ரெண்டு கேசஸ் இருக்கு. அண்ட் வில் சி சம் ஃபங்க்ஷன்ஸ் ஃபார் சைன் ஃபங்க்ஷன், தட் இஸ் ஆங்கிள்ஸ், டு சால்வ் ஆங்கிள் தீட்டாஸ். ஓகே, ஸோ லைக் சைன் தீட்டா, காஸ் தீட்டா, டான் தீட்டா. ஸோ நீங்க வந்து ஃபார்முலாஸ் பேஸ் பண்ணி போவாமே, லைக் ஃபார்முலான்னு சொல்லும் போது லைக் ஃபார் எக்ஸாம்பிள் 15 degrees இருக்கு. ஸோ sin a plus b, sin a minus b. சில பேருக்கு வந்து trigonometry தெரியும், சில பேருக்கு தெரியாது. ஸோ ஃபார் தட் வாட் வில் டூ, பியூர் சயின்ஸ் ஸ்டூடெண்ட்ஸ்க்கு வந்து I'll give some shortcuts மா. ரிமெம்பர் திஸ், இந்த மூணு கேசஸ் ரொம்ப இம்பார்ட்டன்ட். அண்ட் ஒன் மோர் திங் இஸ் தேர், இன்வெர்ஸ் trigonometry இருக்கு, லைக் tan inverse ஆஃப் வேல்யூஸ். இந்த இன்வெர்ஸ் trigonometry வித்வுட் லாக் ஷீட்ஸ் வந்து கொஞ்சம் டிஃபிகல்ட். we cannot able to solve. அது வந்து எப்படின்னா we cannot able to judge it. And whatever we are telling about the angle thetas na, this is for your approximate value. நான் வந்து exact value நான் சொல்ல முடியாது. So I'll help you till your approximate value. Okay, so surely near to the actual value வரும், near to the actual value, somewhat near to the actual value கண்டிப்பா வரும். when you do it, it will be faster only. Okay, இந்த மூணு கேசஸ் நம்ம பார்க்கலாம். அந்த tan inverse terms, inverse trigonometry வந்து we cannot able to adapt it. So logarithms, log sheets எல்லாமே it was pretty difficult for NEET exams. Okay, so இது for the inverse trigonometry they will give the values there itself in the questions. Okay, we'll practice it, no issues. Okay, so just remind me, suppose even if you forget it, please remind me, so it will be useful for you and we have to do it. Okay, right, so is it over? Example 2, please make it fast ma. There are so many problems are there, we have to do it. However, shall we see next question? Okay, so let's see one more. Yeah, so this question, my third one. So calculate the potential at a point P due to a charge of 4 into 10 power minus 7 coulomb located at 9 centimeters away. Hence, obtain the work done in bringing a charge of 2 into 10 power minus 9 coulombs from infinity to the point B. Does the answer depends upon the path along which the charges is brought? Okay, let's see. Second one, first we'll try to find your potential. So to find the potential formula, another V is equal to KQ by R. They have given the distance, they have given the charge, try to find the potential B, first case. So what is the answer, ma, for the charge? I mean, for the potential. Try to find it. Anyone got the answer? 400. இதுமா அதுக்கு யூனிட் இருக்கா? என்ன இருக்கு? என்னது 400? What is 400? Joyce Mary Jones. Volt கிடையாது. Answer is not 400. Answer is not 400. Just think about it. அங்க வந்து 9 வந்து சென்டிமீட்டர்ஸ்ல கொடுத்திருக்காங்க. ஓகே, ஸோ சார்ஜ் வந்து 4 into 10 power minus 9 minus 7 இருக்கு. K value 9 into 10 power 9 இருக்கு. Something you missed it. What about others? Four and yes, man, Niveda, super, correct. So answer is 4 into 10 power 4. Answer is 4 into 10 power 4. So that means K is 9 into 10 power 9 into the charge is nothing but your 4 into 10 power minus 7 by it is 9 into 10 power minus 2. 9 and cancel it. So either on the 10 power minus 2, if it is moving upward direction, so it is 10 power minus 7 minus 9. Okay. And wow, 1 minute. 1 minute. Oh yeah, yes. So either 10 square agum. So 10 square aachina 5. So 4. So it is a 4 into 10 power 4 volt. This is your answer. Now second case பார்க்கும்போது, for the second case, hence obtain the work done in bringing a charge. So there is a charge it was bringing from the infinity location to the point. Okay, so there is a work. So the relation is something about work. Okay, work is equal to or potential is equal to work by charge. And remember, nalla parunga, potential is directly depends. That means work directly depends upon the charge and the potential. W is equal to Q into V. W is equal to Q into V. இங்க பார்க்கும்போது does the answer depends on the path along which the charge is brought. So is it depends upon the R is nothing but your path. So இது வந்து path மேல depend ஆகல. It was depending purely on your charge and the potential difference. So for this point, the answer is no. For this point, the answer is no. Does the answer depends upon the path along which the charge is brought? No, because it doesn't depends upon the distances. R. Okay. So here the W is equal to Q into R. Q we know that is your test charge. So that is nothing but 2 into 10 power minus 9 coulomb. Remember it is 2 into 10 power minus 9 into the potential is 4 into 10 power 4. So what is the answer? Right? What's the answer? Answer ma. What is the answer ma? என்னாச்சுமா ஒருத்தர் ரிப்ளை பண்ணலையே 8 or -5 ஏமா 8 or -5 what about others so okay let's try this one for the fifth question try the fifth question just take it assume it is your homework right take the question homework question so I'll ask you in Monday please solve it take the question Have you taken the question? Okay, this question is your homework, ma. Okay, so கொஞ்சம் solve பண்ணுங்க. Okay, so next Monday, as I told you, we'll discuss about the shortcuts in your square roots and the terms, angle, thetas and all. We'll try to find some shortcuts. It will be useful for you. And I'll ask you some questions from your formulas. Okay, and as well as your units. இண்டிவிஜுவலா நான் கொஸ்டின்ஸ் கேட்கிறேன். ஓகே, குரூப்பா கிடையாது. இண்டிவிஜுவலா நான் வந்து பேர் வச்சு கூப்பிட்டுட்டு நான் வந்து கேட்கிறேன். ஸோ அப்படியே சொல்லிட்டு யாரும் வராம இருக்காதுங்க. ப்ளீஸ் வாங்க. ஓகே, ரைட். ஸோ வில் சி இன் மண்டே. ஓகே, ப்ளீஸ் ப்ராக்டிஸ் இட். ட்ரை டு கோ த்ரூ த கொஸ்டின்ஸ். ஸோ ஆல்ரெடி நான் வந்து கான்செப்ட் நான் எக்ஸ்பிளைன் பண்றேன், பட் ப்ராப்ளம்ஸ் இம்பார்ட்டன்ட். ப்ராப்ளம்ஸ் நீங்க ப்ராக்டிஸ் பண்ணா ஈஸியா இருக்கும். ஓகே, ஸோ ரைட். ஸோ வில் சி நெக்ஸ்ட் வீக். ஓகே, ரைட். We'll see next week. Okay, and those who are preparing for this engineering entrance and all, please stay there, ma. I just want to talk with you people. Okay, ma. Thank you. How many of you? I think 3 members. I hope so. 3 members irkinga nenikren. Yes, Joyce Mary. Joyce Mary, Nia. Nee. Sir, me too. Tarani. Joyce Mary. Yes, sir. Joyce Mary, nee neat dane. Idu eppo shift aayittu nee. Trying both. Multi-talented bunny. Gayatri, sir. Okay, ma. Gayatri. Joyce Mary, Tarani. I think some other girl is there actually. இன்னொருத்தர் இருந்தாங்க. Niveda, yes. Okay. So you people, I think so. 4 members. Okay. So கொஞ்சம் mute எடுத்துட்டு unmute பண்ணா நல்லா இருக்கும். I just want to understand your things. Guru Priya. Okay, super. Okay, so I just want to talk with you because your schools-ல வந்து உங்க content என்ன போயிட்டு இருக்கு, எந்த டாபிக்ல இருக்காங்க, I don't know about that because patterns எல்லாம் சேம் தான், syllabus எல்லாம் சேமா தான் இருக்கும், கொஞ்சம் டிஃப்ரெண்டா இருக்கும் about your patterns and the contents in that. That's it. I just want to understand it. Okay, so நீங்க வந்து யாரும் நீட் ப்ரிப்பேர் பண்றாங்களோ you can leave it, so others please stay here. That's it. So எல்லா பேர் வேண்டாமா. So we'll see in next classes. Okay, and I'll turn off my video.